Debugging distributed systems often means chasing logs across multiple servers. But what if those logs could come directly to your client code? We'll implement a FastMCP log handler that bridges server-side logs with Python's standard logging system, so you can capture structured messages, severity levels, and even extra context, all in real time. You'll see how to map MCP log levels to Python, forward rich log data, and integrate it seamlessly with your existing logging setup.
Import logging. From FastMCP import client. From FastMCP client logging, import log message. Hash in a real app. You might configure this in your main entry point. Logging, basic config. Level equals logging, info. Format equals %. As time, S% name, S% level name, S% message S. Hash get a logger for the module where the client is used. Logger equals logging, get logger name. Hash this mapping is useful for converting MCP level strings to Python's levels. Logging level map equals logging get level names mapping. Async def log handler message, log message. Handles incoming logs from the MCP server and forwards them to the standard Python logging system. MSG equals message, data get MSG. Extra equals message, data get extra. Hash convert the MCP log level to Python log level. Level equals logging level map, get message level upper, logging info. Hash log the message using the standard logging library. Logger, log, level MSG, extra equals extra. Client equals client. My MCP server, Pi. Log handler equals log handler.
This demonstrates the event handler pattern for integrating cross-system logging streams. The code bridges FastMCP's server-side logs with Python's standard logging infrastructure, creating a unified logging pipeline that preserves context across distributed components. What makes this distinctive is its ability to normalize disparate log levels and structure data into a consistent format without modifying the original sources. The pattern works by decoupling log production from log consumption through a callback interface. FastMCP emits log events asynchronously, while the handler transforms and routes them to Python's logging system, maintaining separation of concerns. This design allows the server to remain agnostic about log destinations while giving clients full control over formatting, filtering, and storage, all without tight coupling between systems. This approach solves the common problem of fragmented logging in distributed architectures, where server logs and client logs often live in separate silos. By standardizing on Python's logging ecosystem, you gain immediate access to existing handlers, files, databases, monitoring systems, while preserving FastMCP's structured log data. The trade-off is minimal. You add one transformation layer, but eliminate the need for custom log aggregation tools or manual correlation of disparate log streams. Let's break it down.
Import logging. From FastMCP import client. From FastMCP client logging, import log message.
Imports Python's standard logging for structured log handling and client from FastMCP for server connections. The log message type ensures proper typing for incoming log events from the MCP server.
Logging, basic config. Level equals logging, info.
This sets the minimum log level to info, filtering out debug messages. In production, this reduces noise while keeping operational visibility, ensuring only meaningful events appear in logs.
Hash get a logger for the module where the client is used. Logger equals logging, get logger name.
This creates a module-specific logger using Python's name as the logger identifier. Module-scoped loggers enable precise log filtering and debugging, as each module's logs can be independently controlled by name.
This mapping is useful for converting MCP level strings to Python's levels. Logging level map equals logging get level names mapping.
This creates a mapping between MCP's string-based log levels and Python's numeric logging levels. It enables seamless conversion when forwarding MCP server logs to Python's logging system, ensuring consistent log level handling across both systems.
Async def log handler message, log message, handles incoming logs from the MCP server and forwards them to the standard Python logging system. MSG equals message data get MSG. Extra equals message data get extra.
This is the log message handler that processes incoming logs from the MCP server. It extracts the core message content and any additional metadata from the log message object, preparing them for Python's standard logging system. The pattern follows the adapter model, converting MCP's log format to Python's native logging structure.
Convert the MCP log level to Python log level. Level equals logging level map, get message level upper, logging info.
This maps the MCP server's log level string to Python's numeric logging levels. The get, with fallback to logging, info handles unknown levels gracefully, ensuring no log messages are dropped due to level mismatches.
Log the message, using the standard logging library. Logger, log, level MSG, extra equals extra.
This forwards the MCP server's log message to Python's standard logging system. The level parameter ensures the message gets the correct severity, info, warning, error, while extra attaches structured metadata for context. This bridges FastMCP's logging with your application's existing logging infrastructure.
Client equals client. My MCP server, Pi.
This instantiates the FastMCP client with a connection to the server defined in my MCP server, Pi. The client handles all communication with the MCP server, routing tool calls and managing the connection lifecycle. This is the entry point for interacting with the server's capabilities. Log integration pattern. This example demonstrates FastMCP's client-side log handling by bridging MCP server logs with Python's standard logging system, preserving structured data through the log message interface. The level mapping between MCP and Python logging systems defaults to info when no match is found, which can mask important debug messages if not configured properly. Always verify your level mappings match the server's expected log levels during integration.
The log that arrives without a name carries all names in its silence.